Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A meso compound contains stereocenters yet is superimposable on its mirror image because of an internal plane or point of symmetry. Analysis of each option. A. The cyclohexane derivative shown has two adjacent carbon stereocenters each bearing a Br and H substituent. In the depicted configuration, both Br groups on the same face, i.e., cis relationship, the molecule possesses an internal mirror plane bisecting the ring between the two stereocenters. The cis-1,2 dibromocyclohexane is a meso compound because the two halves of the molecule are mirror images of each other, making the overall molecule achiral and non-resolvable. B. The cyclopentane diol shown has a methyl group and two OH groups at specific stereocenters. With me on a wedge at one carbon, and the OH groups arranged such that an internal plane of symmetry exists within the ring system, this compound qualifies as a meso compound. C. The cyclohexane with multiple Br substituents arranged symmetrically about the ring also has an internal plane of symmetry relating the two halves of the molecule, making it a meso compound as well. Since all three structures, A, B, and C, represent meso, non-resolvable, compounds due to internal planes of symmetry despite having stereocenters, option D, all of these is correct. Why other options fail? Options A, B, and C alone are each individually correct, but since the question asks which compound is a meso compound and all three qualify, the most complete answer is D. Therefore, the correct answer is D. Therefore, the correct answer is option D.